Hello, everyone, and thank you for joining today's session, a practical example for using AI to improve your UI and API testing. I hope everybody's enjoying SauceCon so far. I know I am. My name is Chris Colosima, and I'm the product manager over at Parasoft. And I want to take you through a quick conversation about AI in testing for UI and API, and then show you some demonstrations of how to utilize these technologies. So let's go ahead and get started. So to start with, let's talk about the disruption. Especially in this time that we're in right now, disruption is a key for innovation. We're seeing a lot of organizations that are pushing energy into their online experiences to make sure that they can deliver that seamless experience to those end customers. And I mean, think about other things, like when was the last time you rode in a taxi? Disruption is everywhere, it's constant, and it is a major catalyst for us to be innovative. And the more innovative we are, the more we beat our competition, right? You're seeing this manifest in different ways, right? Digital transformation, people are saying, well, let's bring in Agile to make things go faster, even though we know it doesn't actually make things go faster. Let's bring in DevOps so we can create infrastructure and code and automatically deliver software to the market, right? And we have to do this because switching costs have never been lower. Even people that are non-technical, I was just talking with a friend of mine who was switching away from Gmail because they saw a feature in another email client. Super non-technical person, but there's no switching costs now. We can rapidly go from software to software. And so how do we make sure that we can validate that customer experience and make sure that we're retaining our customers? And it's testing, right? We want to test what works and then make sure that it still works. And so test automation and DevOps is a lot like building infrastructure. You can think of it like a railroad. However, what's coming down that railroad isn't an old-timey choo-choo train. It's a bullet train. And if we don't ensure that we have the proper quality metrics in place for delivering our software, we can get derailed. And you see that train next to that train, the other one, that's our competition speeding right on by, right? And so we want to make sure that we're testing. And the best way to do that is to have a strategy. And here at Parasoft, we believe in building a scalable test automation strategy that aligns with the testing pyramid. And in the testing pyramid, you want to establish a broad coverage or a high amount of those granular test types like API testing and unit tests, which are easier to scale, easier to automate, while minimizing complex and time-consuming late cycle end-to-end testing that's either manual or automated UI. However, when we talk to organizations, what we typically see is the opposite of this, the snow cone, where organizations are focusing on the UI, manual testing, and they're automating what's manual. And we understand, right? It's easier to define those UI tests. They're more difficult to automate, though. And then in the lower levels of the testing pyramid, it's easy to automate API and unit testing, but it requires technical expertise. As we dig a little further in, we do see that organizations are actually starting to pick up on this and try to be better, and they're migrating into more of a martini glass, which is, we're still doing our manual and automated UI testing. We're starting to look at unit testing as an early stage testing practice, but we're skipping right past API testing. And so organizations are still struggling to adopt those lower levels of automated testing. So this is where AI can help us out. But in order to start digging into that, we have to start understanding some of the challenges. And so we run polls all the time at Parasoft. One of the questions that we ask of everybody is, when it comes to UI testing, how are you testing your UI? What software are you using? And unsurprisingly, the vast majority of people are using Selenium. It is the de facto standard when it comes to validating the UI. But when we ask people, how's that going? They say, we love Selenium, but there's challenges. Well, what are those challenges? It looks. Hello, everyone, and thank you for joining today's session, a practical example for using AI to improve your UI and API testing. I hope everybody's enjoying SauceCon so far. I know I am. My name is Chris Colosima, and I'm the product manager over at Parasoft. And I want to take you through testing as an early stage testing practice, but we're skipping right past API testing. And so organizations are still struggling to adopt those lower levels of automated testing. So this is where AI can help us out. But in order to start digging into that, we have to start understanding some of the challenges. And so we run polls all the time at Parasoft. One of the questions that we ask of everybody is, when it comes to UI testing, how are you testing your UI? What software are you using? And unsurprisingly, the vast majority of people are using Selenium. It is the de facto standard when it comes to validating the UI. But when we ask people, how's that going? They say, we love Selenium, but there's challenges. Well, what are those challenges? It looks like it's all about making tests that can continue to execute even though your application is changing, right? And so it's all about maintaining those test cases. We then see, as we start going down a little bit, access to OS and browsers, identifying which tests to execute. And we have solutions for that. But what I really want to talk about today is the execution and maintenance challenges. So these are our challenges. This is what it really breaks down to. Maintaining test automation on the UI due to wait conditions, maintaining due to locator changes, maintaining those tests when the UI changes, debugging and diagnosing failures when they occur, and then reducing the overall time for the test suite to execute. And at the bottom, we see the knowledge and skills to create the scripts. We're seeing people are becoming more technical. It's not as much of a challenge to create those scripts, but really depending upon who we talk, that can change. So what I want to do is I want to talk about maintenance. And so to do that, I'm going to bring in my IDE. So here I am inside of Eclipse. I have a series of Selenium tests that I am executing against my application. I execute them in Sauce Labs, and it's, anybody who's at this conference knows that's pretty straightforward to do. You simply define your desired capabilities, execute up inside of Sauce Labs, you're good to go. For this demonstration right now, though, I'm going to execute these locally. And so I've created this test. I'm pretty proud of it. A couple of reasons. One, it's a Selenium test. It's executing against some pretty critical functionality: accounts, bill pay, request loan. I've created this one in JUnit 4, and I'm using the page object model. And so for those who are unfamiliar, the page object model is an industry standard best practice that allows you to define the pages that you interact with as objects, reusable objects. You can then define your element locators on those objects, and then they will be referenced throughout the rest of your test case. This is great because it puts all of those element locators in one spot. So if you need to make a change, you just change it in that one spot and it propagates through the rest of the test. I'm also using an annotation system through Parasoft, which allows me to associate my Selenium tests with my work items in Jira. And it's for these reasons that it makes me really frustrated when this test case breaks due to the application change. And so I'm gonna run you through an example of how Parasoft uses AI to solve that challenge. So to start with, I'm just going to go ahead and execute this test against my current application and just make sure that everything works as I expect. So I'm just executing those tests against version 1. Okay, that was my accounts test. Looks like that guy was good. Now comes my bill pay test. Okay. Yep, looks like that was good. And then here comes my request loan test. Okay, great. All three of my tests are successful. They work against the current version of the application. Now, development has told me that there is a new version of the application that's available. And there's been some minor changes to that. So what I had was a variable in my test configuration that was pointing my test at version 1. I'm just going to change that to point at version 2, and I'm also going to activate Selenic. So this is Parasoft Selenic. It's a plugin for both the Eclipse and IntelliJ IDEs. It allows you to continue to run your Selenium tests exactly the same way you would, but you can generate recommendations on failure, use AI to perform self-healing, understand performance expectations, and create API tests. You see this as a plugin here for the IDE. We primarily use it through the command line, through our build system, but that's kind of a boring demo. So I'm showing you it in the IDE today. So what I'm going to do is I'm just going to activate it. I'm going to turn it on, and I want, if something fails in this new version, tell me what failed, and give me some information about how I can fix that. So let's go ahead and run this. So now we're running these tests against version 2 of my application. All right, popping up. Okay, looks like the first test was successful. Maybe there were no changes. Spoiler alert, there's changes. Okay, here's test 2. Yeah, right? And so here's where the test looks like it might be breaking. Maybe there's something wrong with zip code or phone number. I don't remember what this looked like in the first version, but oh, okay. So it looks like that test is broken. Okay, well here comes the third test. Yikes. So now that is a very different UI. It looks like there's something that's changed with the loading content. Maybe, nope. Okay. So 2 of my tests have failed. New version of the application. This stinks because now I have a bunch of changes I need to make. The good news is Parasoft Selenic was watching. And so we can see it's running the Selenic analyzer right now. And in a moment, it's going to provide us with a report. So here's the Selenic's report. And so what Selenic is telling us is, hey, I watched that execution. And during that execution, I noticed that you had 1 test that passed and 2 tests that failed. It'll list out the names of the tests down here so we can see all the tests and understand which ones failed. It also says that we believe that those failed due to bad locators or wait conditions and potentially something else. So if we look down here in Selenic's report, we see those tests along with their failure codes. Here it says something about payee phone number, tried for 10 seconds, couldn't click. It provides us with a screenshot so we can see where things broke down. And also, you'll see here that it's provided us with recommendations. So this is where we can see Selenic's AI at work. So let's just click on that. So here what it's saying is that the reason that test failed was because it couldn't click on phone number. And the reason it couldn't click on phone number was because that became a dynamic ID. It changes every single time, which is pretty familiar to those folks that are testing Salesforce and Guidewire. Selenic has recommended, though, a new set of locators that we could use in our test to overcome this challenge. And it has a 96 and respective 95% confidence factor that these will work. And that's based on running the tests over time, going backwards, making sure that it would work, trying and building a new locator, seeing if it works in that, and then providing a stability index, as well as weight, which is a way that we can customize certain strategies like XPath or CSS or text length over others. If, for example, you don't like XPath and you want to use text link, you can prioritize those higher. All right, it's also provided us test details and a stack trace so that we can understand and feel confident in using these new locators. Now, we've got a second one here where a click was intercepted, but we'll talk about that in just a second because it wants us to do self-healing for that. Let's deal with this. Let's deal with this element locator here. So to do that, I come back in the IDE, and typically you'd have to go and search to find that element locator. But Selenic can take us directly to the line of code that needs to be changed, and right here in the IDE, make that change and update that locator. This test is actually now good to go. This test would pass. But wouldn't it be cool if Selenic could self-heal those locators and wait conditions at runtime? See, in order for that to work, I had to have a test that failed. And I don't want that. I want tests that pass. I want to get those validations. But I also want to know when I have a test that I need to fix. So what I did was I went ahead and reverted the change. I broke this test. Let me go ahead and save it. And now I'm going to run this with the self-healing. Now what self-healing does is it takes those AI-powered recommendations and it tries them out. And it says, hey, you know what? Maybe I'll try this locator, then I'll try this locator. I'll try a different weight condition. It tries different things to make the tests more stable and more maintainable. So let me go ahead and run this, and we'll see this all happen. Now we know that the first test that we executed was successful, so that's not going to be that big of a show here. Okay, now here comes the second test. Now this is going to happen a little quickly. It's going to fail in the UI. Look in the bottom right-hand corner. you'll see the self-healing get triggered. It says, oh, I'm going to try a new element locator. Back in the UI, it finds that element locator, provides the information, the test proceeds. Okay, now let's look at this new UI. So it turns out that the reason this is failing is because that loading button is intercepting the click. So what Selenic's going to do is it's going to initiate self-healing, wait a little bit longer, and then click the button. Okay. Well, here we go. That looks a little different. Now we've got 3 tests that are successful. Let's look at that report from Parasoft Selenic. Okay. So here we see, not only did we get the 2 tests healed, but we also see that we've got some information about how they were healed. And if we were to drill down in this, it would say, I couldn't do this, so I tried this, and I was successful. So now you should fix your code. We don't use the AI to automatically fix the code. We still want humans to fix the code. Now in this second one, it says, yep, I did something. I self-healed the test. Well, what did you do? Oh, it waited a couple of seconds longer for that element to not be obscured. And it recommends updating the function to use a fluent wait, which we could then apply back into our code. And so this is a great example of using AI to solve a test maintainability challenge of Selenium testing. Now, there's one additional thing here. It's not really the purpose of today's conversation, but it is worth noticing. I also have some performance thresholds that were exceeded. So since Selenic is monitoring all the executions, it times them. And if performance tests start taking longer, if UI tests start taking longer than they should, it lets us know. And it makes it easier to start identifying where our performance issues may be. Okay, back in the IDE, I could use that locator to then update my test case and make it so that my tests are successful and easier to maintain. So if we jump back here into this demonstration, what we just did, we created some Selenium tests. Now, I didn't show you that now. I'm going to show you that a little bit later when we get into the API tests. We do have a recorder that allows us to create pure Selenium tests, and while at the same time, create some API tests. Then we execute those tests. We can execute those in Sauce Labs so that we can get all the benefits of executing across a variety of browsers. But if we have a test that's broken, Selenic can retry and self-heal those Selenium tests at runtime, and then deliver those recommendations back to us in our IDE. Now, additionally, because we have the annotations connecting with the system, with the work items in the system of record, we can then deliver those back to systems like Jira, X-Ray, CollabNet version 1 for traceability to understand how our Selenium tests are covering the requirements. And so, really, the key here with the AI is that retrying and self-healing to make Selenium tests more maintainable. But what about API testing? Right? So when we talk to different organizations about API testing, we get this list of pros and cons. Right? It's a maintainable type of test automation that allows you to really drill down onto the specific challenges in an application, identify that at an API layer, get great coverage, and then reduce the time between defect identification and defect remediation. Right? It's a really effective communication channel for testing. They're more stable and more maintainable than your UI tests because APIs tend to change less than UI tests. But if API testing is so powerful, how come we don't see so many people doing it? And it's because there's some cons associated with it. It is a more technical testing type. It requires you to really understand the relationships and the correlation between different API tests and API chains. And so testers either don't understand those rules and how the APIs work, or they don't have the skills or the tools required to build rich API tests. There's also this really interesting thing that happens when we poll API testers and developers. We see that about 50% of testers say, it's development's job to test those APIs. When they're producing them, they should then, as a part of their unit testing framework, test the APIs, make sure everything works. 50%. But 60% of developers say, no, it's test's job. We created the API, we create the Swagger or the Open API specification. It's the first user accessible interface onto the application. So just build the API tests against it. So it is a little bit of no man's land. Now at Parasoft, there are two strategies for building API tests. The first one is from the bottom up, where you focus on the individual component. And this is use the service definition, create API tests individually against those APIs. And this is sort of your traditional type of API testing, where you're going to Swagger, picking out your API, putting it in there. But the part that's challenging about this is, how do I know which APIs to use? How do I know how to chain them together? What data do I use? And that's where AI can help us. And so we can create API tests from the top down by creating API test scenarios that emulate the usage of our UIs and tell us, well, what APIs were being used in the integrated system. So let me show you a demonstration of that. Now, remember at the beginning I said that I created those tests from recording? I want to show you how that happened. So I'm going to go to my my Parabank application. And so here inside of that Parabank application, what I want to do is I want to add another test to my Selenium tests. The Parasoft recorder allows you to build UI tests in pure Selenium for Parasoft Selenic, as well as building API tests at the same time. So let me go ahead and start recording this. Okay, so now I'm just going to log into my application. Bear in mind, I'm recording the UI and the API actions at the same time. I'm going to come to this transactions page here. I'm going to search for a transaction by, $100. Let's say this is some new functionality that I have in my application. Okay, and I'll just click on this funds transferred received. Great, that's my scenario. So I'm going to go ahead and stop recording. Now I'm going to get two screens. The first screen says, okay, what UI action do you want to create? All right, I'm going to create one called find transactions. And I'm going to associate a new requirement with this, par 22. Oops. Par. Parabank. Okay, now I'm going to download that recording, and I'll do something with that in just a second. But I can also create those API tests. So I'm just going to also call this API test find transactions, and I'll say create test artifact. The AI is going to think for a second. There we go. Now we have a test. All right, what do we want to look at first? Let's go ahead and look at that UI test first. So to do that, I'm going to jump here back into my Eclipse IDE. And so here we see that we ran 3 tests. I'm going to go ahead and just add a new test to this by right-clicking and saying create Selenium test from recording. Now I could do what I'm going to do here is I'm going to add that new test. Let me close this. I'm going to add that new test in here, but I could also just create a brand new Selenium project from recording if I just wanted to start from scratch. But here I'm just going to add this in. I'm going to go ahead and say create Selenium test from recording. We'll point to that find transactions desktop downloads. Right here, we'll pop this guy in, finish. We'll see a couple of things happen. One, my test is now updated. I now have a 4th method called find transactions. Here's all my Selenium code. Excellent. I also have new page objects, okay, where this is the transaction that I just created. So that's great. And so now I can actually run this test using Parasoft Selenic. And we'll just run it against the original application. And now we should see 4 tests fire off. Okay, here comes the first one. And this is great because you can just, oh, actually that was my transactions test. It ran that one first. That's great. It just makes it easier to really take advantage of that page object model strategy. And when you have new UIs and pieces that are available, you get those great new tests. Okay, 2, 3, 4. Here comes that 4th test. Okay, everything was successful. Great. I recorded those UI tests, but I also recorded those API tests. So let's go find those API tests. And to look at those, I'm going to jump here into Parasoft SOA test, which is the API testing tool. It looks similar to the Eclipse interface that you see for the UI testing Selenic tool. But look, here's my API test. All right, let's go ahead and open this up. So here are all the API calls that were made as we were interacting with that system. And so here we can see that we were requesting, getting into our accounts, finding the transactions. Now, what's cool about this is that I have confidence that this test will work. How did I know that test was going to work? And that's where the AI comes in. So if I expand this, you'll notice here that we have a whole bunch of tools, smart data banks, assertions. Now, what's happening here is that Parasoft SOA test is looking for patterns and relationships in the request objects. And in each client, there's things that need to be exchanged, such as session information, data, potentially building assertions, because we're seeing data values change. This is where the AI comes in for API testing, and it makes it much easier to build these complex chains of API tests without having to really understand all of the underlying interfaces. This is also great because as a tester, since I know this was the find transactions flow, I can start to become more knowledgeable about how those APIs work. Now, if there's something that I need to change about the test, maybe I need to change the authentication, maybe I need to add a new assertion, I can make that change in the test and then train the underlying AI how to do things better in the future. Now, when you train the AI, that all shows up into the smart test templates, which are a series of endpoints associated with your different APIs. And if you have rules for those different APIs, all of that plus your assertions show up here. And it just makes it much, much easier to templatize all of the business rules of your APIs. The more that you use the machine learning and the AI, the smarter the tool becomes, and the easier it becomes to build these great API tests. Now, what I want to do, though, is I want to bring these two things together. I want to build some great API tests from my existing UI tests. And so to do that, I'm going to jump back here into Selenic. And so I have these tests. These tests have all these different methods in them. What I'm going to do is inside of my run configuration, I can simply specify for these tests to, at the same time that they're running, create the API tests inside of SOA test. So I'll go ahead and say, OK. I'm just going to go ahead and run this. And then we pop open SOA test here, kind of move this guy over to the side for a second. OK, and we'll see these tests are starting up. OK, so there was my first one. Find transactions, great. Nope, see, we got our little API test right here. Here comes my second test. It's not popping open. There it is. That was bill pay. And then here comes my third test. This one is, okay, this one's bill pay. So that one's creating the bill pay API test over there in SOA test. And then here comes my fourth test. This one should be request loan. Yep, there it is. Has to do some self-healing here, but that's okay because those API calls will be made under the hood there. Okay, and there comes my fourth test. All right. And so this is a great way to leverage the existing Selenium tests that you have. Oh, get rid of this report to create API tests. You could then arrange these API tests according to your application and the requirements, and then execute them together to get maximum coverage and really rely on that AI to ensure that everything runs smoothly. Okay, so what we basically just did there was we created the API tests from usage. When we recorded the UI tests, we simultaneously created those API tests. We leveraged AI to then drop API test scenarios into SOA test. Additionally, we could reuse those existing Selenium test scripts that we have, and we know we have lots of them. And any REST JSON API calls that are made in the front end, we can capture those and use that AI to create those great API test scenarios. And so At Parasoft, we believe that through our different technologies, we can really realize the testing pyramid. And it really does start with a solid foundation of unit tests and code analysis through static analysis of applications through Java applications through our JTest product. Moving up the chain, we can use SOA test and Smart API test generator to build API tests from design or from usage, and then run those tests under load to get great API test coverage. Service virtualization allows us to simulate components in our environment that are unstable or out of our control to create realistic test environments for testing anytime, anywhere. And then Parasoft Selenic makes it really easy to reduce the complexity associated with Selenium testing. All right, well, we're just about out of time here. I really hope this was valuable to everybody. I'm going to go ahead and throw up some links. So if you do have any questions, reach out to us at parasoft.com. We'll also grab a record of the chat here and see if we can connect with you guys directly. But thank you, everybody, for your time, and I hope you enjoy the rest of the show.